Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at a section 11.3, which is going to deal with corresponding parts of similar figures. Now, for today's lesson, we have one learning goal, and our learning goal for today is going to be that you will be able to find the measure of side lengths and angle measures given that two figures are similar. So that's going to be our goal for today. And corresponding parts of similar figures is going to be closely related to that corresponding parts of congruent figures. Difference here is we're not talking about congruent, but we're talking about similar figures. And we're going to use those properties of similar figures to help us solve for our problems today. So let's talk about what those properties of similar figures are before we jump into our examples for today. So the first property of similar figures is corresponding angles of similar figures are congruent. So when we have two figures that are similar, what we know about the angles is that they are the same measure. They are congruent to each other. So corresponding angles are congruent. So if we're talking about if triangle ABC is similar to triangle XYZ, this little squiggle just means similar. If these two triangles, ABC and XYZ, are similar, then angle A is congruent to angle X, angle B is congruent to angle Y, and angle C is congruent to angle Z. So corresponding angles are congruent. Now the second property is corresponding sides of similar figures are proportional. So what we're going to do with this is we're going to essentially take the concept of scale factors that we've talked about with dilations and carry that into this as well. So side lengths are proportional, which means we're going to set up a proportion of AB over XY equal to BC over YZ equal to AC over XZ. So we're not just going to straight set AB equal to XY, yet we have to do AB over XY equals then another fraction of the side lengths. So you're going to set up fractions of the side lengths, so AB to XY equals BC to YZ. So that's what we're going to do with side lengths. So angles are congruent, side lengths are proportional, just like we have here. AB over XY equals BC over YZ equals AC over XZ. That's going to be similar to the dilations and figuring out that scale factor. So, keeping that in mind, we're going to move on to example 1. So I'm going to slide this on up real quick. Alright, example 1 wants us to identify properties of similar figures. So we're going to go through and utilize those properties to help us answer the following questions. So for example 1, part A, it says figure EFGH maps to figure RSTU by similarity transformation. Okay. Write a proportion that contains EF and RU. List any angles that must be congruent to angle G or congruent to angle U. So let's take this first situation. So we have the fact that EFGH maps to figure RSTU. So if we're saying these two figures are similar, okay, that's like having triangle ABC is similar to XYZ. So if I were to set up a similarity statement, like a congruent statement, that's going to get us off and started. Now, much like what we dealt with congruent statements, where order mattered and where you could figure out that angle E is congruent to angle R in congruent statements, because first letter, or first and second, and so on, that same concept applies to similar statements, that order does matter. That if I'm pulling the fourth letter That means the fourth letter in this statement that these two angles are congruent to each other. If I took these middle two letters for a side length, then they would be proportional to the middle two letters in this statement. So very similar to congruent statements, it's just that we are dealing with similar figures. All right, now it wants us to write a proportion that contains EF and RU. So we're going to deal with EF first, and then we'll come to RU. When we're talking about a proportion, it's going to be a fraction equals a fraction. So if we start with EF, EF happens to be in the first statement, so we're going to put that on top. So EF, because it's from the first statement, is going to go on top. And then what we're going to do, if EF is the first two letters in this statement, then we're going to go look at the first two letters in the second statement, which in this case is RS, and that's going to be what's going to go on the bottom of that fraction. So I've set up one part of my proportion that contains EF. Now to have a proportion, we have to set them equal to each other. And the other thing they want us to contain is RU. RU is going to come from the second statement, so that needs to go on the bottom of the fraction. And RU is the first and the last letters in this statement. So the first and the last letters in this statement are going to be EH. And that is going to complete our proportion that contains EF and RU. So EF and RS, first two letters, equals EH, first and last, over RU. So EH, first two, or first and last, and then RU is first and last. So I now have a proportion that contains EF and RU. And that's the answer to that part. Now, for the other part, it talks about list any angles that must be congruent to angle G or congruent to angle U. So let's start with angle G. So we need to go through and identify what angle or angles must be congruent to angle G. So G is the third letter in the first statement. So then the third letter in the second statement is 1, 2, 3, angle T. So that means angle G must be congruent to angle T. And then they want to talk about for angle U. So what angle must be congruent to angle U? Well, U is the last letter in the second statement. So the last letter in the first statement is angle H. And then that is going to give us our full and complete answer for example 1, part A. So setting up a proportion containing two different side lengths is the red. Then finding different angles that must be congruent is what we see in the blue and purple. So that is our answer for part A. I'm going to give one more of those another chance, and that's what we're going to see in part B. So I'm going to go ahead and slide this on up so we can take a closer look. All right, for part B, it states figure JKLMN maps to figure TUVWX by a similarity transformation. We need to write a proportion that contains TX and LM, and then we need to list any angles that must be congruent to V or congruent to K. So let's start with this proportion. So that's going to be very similar to what we did right here. So first, they want us to write a proportion that contains TX and LM. So let's start with TX. Now, TX is going to come from the second statement. So that means it's going to go on the bottom of this first fraction. TX is the first and last letters of this statement. So the first and last letters of the first statement are J and N. And if we're setting up a proportion, it's going to be a fraction equals a fraction. So we have Jn over Tx equals Lm is going to come from this statement right here. And Lm is the third and fourth letters. And since it's from the first statement, it goes on top. So then we're going to pull the third and fourth letters from the second statement. So the third letter is V, and the fourth letter is W. And that's going to go on the bottom part of our fraction. And then that is going to complete our proportion that contains Tx and Lm. So I contained Tx and Lm, and we do have a true proportion because Jn and Tx are the first and last letters of both statements, and Lm and Vw are the third and fourth letters of each statement. Next, we need to go through and list any angles that are congruent to angle V or congruent to angle K. If we start with angle V, okay, V is going to be the third letter in the second statement. So the third letter in the first statement is going to be L. So angle V is congruent to angle L. Next, we have angle K. So angle K is the second letter in the first statement. So the second letter in the second statement is angle U. And that is going to be the angle that is congruent to K. And that is our answer to part B. So when you get to the homework, if you see any problems like example 1A or B, that is going to be your goal for those problems. Set up a proportion or tell what angles are congruent to each other. So that is how you do parts A and B. Next, I want to take a look at C. So the ones from here on for C, D, E, and F are going to be a little bit different than what we did in A and B. And they're good ones to run through just to give you different examples to reference for the homework. Now for C, it states that triangles ABC and DEF are similar. They want us to go through and write the congruent statements. Now, congruent statements means that they have to be congruent to each other. So if we have triangle ABC and DEF are similar, what we know about similar figures is that corresponding angles are congruent and that corresponding sides are proportional. Because this wants the congruent statements, all we can deal with is the angle measures. If it wanted us to write the proportional statements, then we would deal with the side lengths. This one just wants the congruent statements, so all we need to do is state what angles are congruent to each other. So angle A is congruent to angle D because A and D are the first letters in each statement. The next would be angle B and then angle E because they are the middle letter in both statements. And then lastly, we have angle C and angle F are going to be congruent to each other because they are the last letter in both statements. So if it wants you to write the congruent statements, know that we are dealing with the angle measures. If they want proportional statements, they would want you to deal with the side lengths. And that is our answer to part C. All right, next, let's take a look at part D. So for part D, what they want us to go through and do is triangles PQR and LMN are similar. If QR equals 6 and MN equals 9, it wants to know what similarity transformation in coordinate notation maps triangle PQR to triangle LMN. So because we were talking about similarity transformations, okay, the one that's going to map PQR to LMN, because we're talking about similar figures, is going to be a dilation. And then it wants us to go through and write it in coordinate notation. So we have to go through and write this dilation. That would be the x comma y goes to something x comma something y for this coordinate notation. Now we have to figure out scale factor, and when we're figuring out scale factor, remember it's prime over original. So what we're going to do is take the second one, which is going to be mn, over the original, which is qr. So we're going to have 9 over 6, which would simplify to 3 over 2, or 1.5. So now that I have my scale factor, to write this in coordinate notation is you could either do 3/2 x comma 3/2 y, or you could do 1.5 x comma 1.5 y. Either way works. Both of them are true statements. It just depends if the site would want you to do fraction or decimal. But remember, when you are figuring out scale factor, it has to be the prime over the original, the new over the old. So because we went from this triangle to this one, that means that this one needs to be on top and this one needs to be on the bottom. So we went from 6 to 9. And if we do 6 times 1.5, we end up with 9. And then this is going to be our answer back there. So that is how you do a problem similar to example 1, part D. All right, the last ones are going to be E and F. Now for E, it talks about CDEF maps to JKLM with the transformations. X comma y goes to 5x comma 5y to x minus 4 comma y minus 4. It wants to know the value of EF over LM. Now, at first this problem may seem terrible and not fun to complete. This one really, though, isn't too bad. Really, all you need to focus on is the xy in whenever you multiply or divide. So essentially, we could ignore the minus 4 part, and we just need to focus on these two. EF is from the first statement, and LM is from the second. So EF is going to be the original transformation, so this XY. So that means we're going to represent EF as 1, because there's that hidden 1 in front of the X and Y. And then for LM, because we had to multiply by 5, that means that we took that quadrilateral and we times it by 5. So that means this 1 goes to 5. And then that is our answer. So all you need to really do for those ones is just look at whatever is being multiplied. See, this xy is the original, so that's where the 1 comes from. And then this 5x comma 5y, it's multiplied by 5, so 5 is going to go on the bottom. We don't worry anything about plus or minus anything when you deal with these problems. All right, lastly, before we move on to example 2, for f, it states PQR maps to VWX with the transformation XY goes to x plus 3, comma y minus 1, goes to 2x, comma 2y. If WX equals 12, what does QR equal? Now, we're going to set this one up similar to what we did over here. So, first of all, we're not going to worry anything about the plus or minus. All we're going to be focused on is multiplying or dividing the dilations. So, we want to know what QR is. QR is going to come from the first statement, so that's going to be on top. And then we are going to take the fact that these are the last two letters in the first statement. The last two letters in the second statement is WX. Now, I know that they tell us WX is 12. We're not going to worry about that at the moment. First thing we need to do is figure out the value of QR over WX, much like we did here with EF over LM. PQR is the first one, so QR comes from that first statement, so that's going to be 1. And then WX comes from the second triangle, and we've multiplied by 2, so that's going to be over 2. All right, so if we have 1/2, now what we're going to do is set this equal to, if WX is 12, and then we want to figure out what QR is. So we need to figure out that value of QR. So what we're going to do here is just cross multiply and then divide. So if we cross multiply, we get 2 times QR equals, and then 1 times 12 is 12. And then if we just finish off solving, divide by 2, we find out that QR is 6 units long. And that is how you do part F. So that is example 1 on using the properties of similar figures, where corresponding angles are congruent and corresponding sides of similar figures are proportional. So I know there's a host of different problems that took place, but that should give you an example of each type that you would see in the homework. So that should be extremely helpful to you. So either tune back to the video if you need help on the homework, or you can always reference my completed notes for further guidance or reference. So that is example 1. Next, we need to take a look at example 2, where we're going to use these different properties, that angles are congruent and that side lengths are proportional, to help us find the value of x and y. All right, for example 2. Example 2 states that given that the two figures are similar, they want us to go through and find the values of x and y. Math would not be math without having you solve for x and y. 2 things to keep in mind. Whenever you are dealing with angle measures, they are congruent. If you know that angles are congruent, like we do, then you can set them equal to each other to solve for x or y. If we're dealing with a side lengths are proportional, which means you need to set up 2 fractions of the side lengths and then set them equal to each other, cross multiply, and solve. So, first step, we have example 2a, where we have trapezoid ABCD and PQRS. what we need to go through and do is figure out what x and y equal respectively. So let's start with x. Now, in this problem, the only place I see x is this 4x plus 27, because we have 4y, 3y minus 5, 5, 10, 95 degrees. So, this 4x plus 27 degrees. This angle right here, just by looking at this trapezoid compared to this one, is going to be congruent to this angle R. Also, we know that because that's the only information they gave me on angle measures, so odds are they are going to relate to each other. Now, because we're talking about angles, angles are congruent, so I know that angle C is congruent to angle R, and if I know two things are congruent to each other, that means I can set expressions or values for those equal to each other. So C is 4x plus 27, so we're going to take 4x plus 27 and set it equal to R, which is 95 degrees. So now that I have 4x plus 27 equals 95, all we need to do is just go through and solve for x. So we're going to use our algebra skills of subtracting, then dividing to solve for x, to then figure out what the value of x is. So first step is to subtract 27. So 95 minus 27 is going to be 68. So we have 4x equals 68. And then our last step is to divide. So we're going to do 68 divided by 4. And when we do that, we get x to equal 17. And our answer for what x equals, for example 2a. So now that we have figured out what x equals, our next goal is to go through and figure out what y equals for this problem that allows these two figures to be similar. So if we look at this, we have a 4y and then a 3y minus 5. And we also know that PS is 10 feet and that PQ is 5 feet. So knowing that bits of information, remember side lengths in similar figures are not congruent. So unfortunately I cannot just set 4y equal to 10 or 3y minus 5 equal to 5. Yet side lengths are proportional, so we have to set up a proportion. So if we start with AB, the side AB is going to be related to the side PS. So if we start with that, so we have AB over PS, that's going to be equal to, we have to take another set of side lengths to set up a proportion, AD over PQ for our other fraction. So now that I have my proportion set up, where I took AB over PS equals AD over PQ. Okay, I just took the sides that were corresponding to each other from the shape. Now that I have my proportion set up, we're just going to plug the values in for each side length. So if we do that, AB is 4y and PS is 10 equals AD is 3y minus 5, and that's going to be over PQ is going to be 5. So now that I have 4y over 10 equals 3y minus 5 over 5, all we have to do here is just cross multiply, and then we solve. So if we cross multiply, if we have 4y times 5, 4 times 5 is going to give us 20y, and that's going to equal 10 times 3y minus 5. 10 times 3 is 30y, and then 10 times a negative 5 is going to be minus 50. So I now have 10y equals 30y minus 50. Solve for y using your algebra skills, and that will give you your answer. So if we have 20y equals 30y minus 50, I'm going to move this 30y over to the 20y. So 20 minus 30, and I'm subtracting because this 30 is a positive. So we end up with negative 10y equals negative 50. And then all we have to do here is divide. So negative 50 divided by negative 10 is going to give us 5. So in this case, y equals 5. And that is our answer for the second part of example 2, part A. So we've now found x and we have now found y, and that is our final answer. Now, your goal from there is just to kind of run through that same setup for parts B and C. Now, I'm not going to run through every step in solving, but I will get them set up for you, and then you can solve from there. So if we look at part B, for example 2, all right, for part B, we have the shape JKLMN, and then VWXYZ. So we have these two different 5-sided shapes, and we need to go through and figure out x and y. So first of all, if we want to go through and solve for x, we see that we have 5 times x minus 5 for angle M, and then we see for angle y, we have a 4x. Those two angles appear to be about the same spot for both figures, and because we know angles in similar figures are congruent, that means that I know that angle M is congruent to angle y, which tells me that 5 times x minus 5 equals 4x. So your goal for this problem is to then go through and solve for x. Distribute the 5, move the x to one side, and then divide. For this one, if you want to go through and solve it, you should get x to equal 25. Next, we have to solve for y. So for y, in this case, we're going to deal with the side length because we have 2y minus 8. So we're going to take the side jk, and that's going to be proportional to the side of VW. Now, if we're setting up a proportion, we need another set of side lengths. Well, they tell us the value of MN, and that side is going to be related to ZY. So if we have MN over YZ, that's going to allow us to set up our proportion. So if we set up our proportion, we know that JK is this 2y minus 8. We know that VW is 4. And then that's going to be equal to MN is 1.5. And YZ is going to be 1. So we have 2y minus 8 over 4 equals 1.5 over 1. Now that you have your proportion, you would cross multiply, and then you go through and solve for y, And if you go through and do that, you should get y to equal 7. And that is your answer for part B. So went through and set it up for you, gave you your final answer. If you want to practice solving those for x and y respectively to see if you can run through the algebra correctly, by all means go through and do it. It's also done on my completed notes if you would like guidance on what I did with each step. All right, last one that I want to set up, and then we are done. For C, it's going to be a little bit different, so I would like to walk through it briefly. We have two triangles, and one triangle is inside another triangle. So we have ABE and then ACD for our two triangles. First of all, X, yet again, is going to deal with the angle measures of angle B and angle C. Angle measures are congruent. So I know that angle B is congruent to angle C, thus allowing me to set it up as 3x plus 14 equals 50. So your goal from there would be then to go through and solve for x, subtract the 14 and divide by 3, and that will give you your answer. For the side lengths, okay, so we have this 5.6, this y, and then 5 and 4. First of all, it should be fairly apparent how to set up the proportion for the 4 and the 5, as this should be EB over DC. The key, though, is setting up the other side. Okay, if EB is for the smaller one, that means our smaller side length is AE. And then our larger side length is not just going to be this little part here, but it has to be the whole thing of AD. Okay, we're not just focusing on these little sections here, but the whole larger triangle and then the smaller triangle at whole. So if we set up proportions for this, if we plug in the values, we would end up with EB is 4, DC is 5. Nothing too revolutionary there. AE is 5.6. And then the key for this problem here is for AD, it's not just Y, but AD is this whole thing of 5.6 plus Y, because it's AE plus ED. So we need both of these parts. So it's going to be 5.6 plus Y. And then that's going to be your proportion. So don't just set it up as 4 over 5 equals 5.6 over y, because that's taking this little part, and you took the whole side length of DC, so you need to take the whole side length of AD as well. And then that's going to give you 4 over 5 equals 5.6 over 5.6 plus y. We take the 5.6 plus the y to make the whole side of AD. Cross multiply and solve, and you should then go through and be able to solve for y. X and y are both solved on my completed notes, so if you want to take a look at those to see if you are on the right track, by all means go ahead and do that. Otherwise, that is it for today, and that is how we are going to go through and use corresponding parts of similar figures and the properties of similar figures to go through and write proportions or congruence statements or find the value for x and y. So with that said, that is it for today on my lesson for 11.3, corresponding parts of similar figures. Thank you guys for listening. As always, if you have any questions, just shoot me an email or let me know the next time you see me. Otherwise, that is it. Remember, as you work on your homework, to either reference back to this video or take a look at the completed notes. Otherwise, thank you for listening. Have a great day, and I'll talk to you guys later. All right, bye.